Hello everyone. So today we will be getting to know about finite automata. Okay, so basically entire theory of computation most probably will be dealing with finite automata. Okay, so it's actually a mathematical model to study abstract machines or abstract computing devices with inputs from summation. Summation is nothing but alphabets, where alphabet is nothing but a character set, a non-empty finite set of symbols, whereas a symbol is a abstract entity, either it might be numbers or alphabets, anything. Okay, next up, where this summation is the set of alphabets using which any string can be obtained. Okay, so this entire thing will be dealing with the alphabets, where the processing will be taking place. Next, on reading the string, the machine may accept it or reject it. The first thing of any finite automata machine's work is to accept the string, process them, and give out some output, whether it might be accepting the string or rejecting it, whatever it might be. Okay, the basic functionality of any abstract machine, whereas an abstract machine is nothing but a conceptual or theoretical model of computer hardware or software system which actually does not exist. Okay, so basically these abstract machines will be dealing with the in theoretical format, not actual as practical as computers, whereas it will be dealing with the software or hardware of a computer which really does not exist. Okay, so this is about the abstract machine. Now after all these fancy terms, we will let us see what actually finite automata means in simple terms. Okay, just for our reference. In simple words, finite automata is an idealized machine to recognize patterns within input taken from alphabet. What actually it means in the sense, basically an idealized machine is nothing but an individual machine which will be recognizing certain set of pattern. A pattern is nothing but a set of or a group of strings or symbols, where we will be giving those group of symbols to recognize something, whether it is apt for that machine or not. Okay, next, an automata is nothing but a machine. As we all know, an automata theory of computation is completely based on a machine. As you have known, what actually a computation is nothing but a step-by-step procedure to solve any problems. Okay, so it's just a basic sense that to solve a computation, obviously we need some device to perform it, apart from leaving the manual work. If we need anything to be computed at par or frequently or consistently, then we will be acting for a machine. So it is actually in terms where automata means a machine. A machine has basically three states. These is all the base state of a machine: initial state, normal state, final state. Okay, this is about the states where everything will be taking into conversion. Next, after knowing all the basic terms, that is automata, machines and their states, let's see what is the childish finite automata definition look like. Okay, finite automata is the type of machine which take finite number of inputs and produce finite number of outputs. So there is no something like putting random number of inputs and getting some kind of outputs generally. So it is more like how much you are giving as an input and how much output you might get. Okay, so that is exactly what the finite automata will be dealing with. If you are giving 5 strings as a variable, then you can expect that 5 string to be recognized, or in the sense whether it is recognized and then whether it is recognized or accepted or rejected will be depending upon the machine, whatever the condition we place onto it. Okay, so this is the most basic definition of finite automata. Now, let us see how the finite automata will look like in a block diagram. Okay, so this is the block diagram of the finite automata, where it includes basic components of it. Okay, so first up, there is three boxes here. First one would be input tape, and next up control unit and output. So what each one defines, let's see what each one actually defines. Okay, so first one, we can see an input tape. An input tape is nothing but it's actually a block divided into smaller cells, that is, entire alphabet will be divided into smaller chunks so that it can be processed easily. So you can see here hello as a string or an alphabet. Here each character is being placed in different cells. This is exactly how it is represented. Fine. So each cell is divided into cell, and each cell has one symbol each. A symbol is nothing but an abstract entity, whether it might be alphabets or numbers or special character, however it might be, whatever it might be. Okay, so next up, this is the control unit. This is where actual processing takes place. Okay, so this is where the string which is being given from the input tape will be processed, and where the conditions will be checked with the inputs, whether it matches the pattern or it does not. Okay, so you can see these q1, q0, q2, so and so. So these all are nothing but the input states. So from one segment to another, how it is being transformed. Okay, so for now, let's just understand that these symbols are nothing but the states. Okay, like we have seen in machines, initial state, normal state, and final state, like that. So so in this control unit, only one input state will be there and one or more final states will be present. Okay, in output, the conditions are satisfied by input, means then the machine will be accepting it. The abstract machine will be accepting the pattern, then giving the output as the string has been accepted. Or if it does not match the pattern, or if it does not satisfy the condition, then it will be of rejected string. Okay, so this is about the finite automata. So we have come across the definition, fantasy definition of finite automata, the simpler definitions of each concepts, and the components of finite automata. So the next part will be regarding the mathematical representations, transition diagram, and table. So let us see in the upcoming videos. Thank you.